Okay, the good news on a volume to volume calculation is that you've already done something very simple to this when we were doing mass to mass stoichiometry. And remember, one of the frustrating things with mass to mass stoichiometry was, as I mentioned earlier, having to calculate those molar masses. And on these problems, you don't have to do that. So let's go ahead and take a look here what we have. We have a balanced chemical equation, which should kind of make us think stoichiometry. Notice those coefficients that are present in front of the different molecules. What will be the volume in liters? So I know that I'm trying to get to liters of oxygen. So I'm going to put that at the end because that's what I'm trying to get to, required for the complete combustion of 0.350 liters of propane. Remember, if you're one of those people that looks at problems and you tend to get a little bit overwhelmed, literally do not even read the problem. Just pay attention to the numbers. Read it just so that you can figure out what your starting units are. In this situation, 0.350 liters. And then let's go ahead and take a look at those ending units of what we're trying to get to, liters of oxygen. And so now I know that to get to liters of oxygen, I've got to cancel out liters of propane. So I'm going to go ahead and drop down C3H8. And then let's look to see how to get rid of this. So we know that the number 22.4 liters represents what? 1 mole of propane, right? Okay, so far so good. Now we want to get rid of moles of propane. So let's go ahead and drop that down. Drop down moles of C3H8, which is propane. And here is that step that even with the mass to mass trips some of you all up, you're trying to get to oxygen. And this is that transition step. This is where we're going to use that mole ratio to get to oxygen. And so just like in a mass to mass problem, we see mole over mole, which means we're looking to the mole ratio, and we've got to look at the coefficients in front of each compound. I see a 5 in front of the oxygen. I see a 1 that's understood there. And last step, we're going to drop down moles of O2. And look, once again, what you have here, moles and liters. And what is that relationship? We're going to go ahead and write 1 mole of O2 represents 22.4 liters. Now, the one thing that I'm noticing here is that nowhere in the equation did it say anything about STP, but please forgive your teacher's mistake there and make the assumption that this was at STP. Now, look at what can happen here. The 22.4s are going to cancel out, and so what you end up with is simply 0.350 times 5, and that is going to give us 1.75 liters of oxygen. And yes, it is that simple. See how nice and quick that was? We didn't have to calculate any molar masses whatsoever. So again, a volume to volume problem is actually a lot simpler than the mass to mass that we have been doing.